For decades, astronomers were confident that no single object in our galaxy could be older than the universe itself. Then, deep inside a tightly packed swarm of ancient suns, their instruments measured a cluster that seemed to break the laws of physics. The numbers pointed to an age so impossible that the lead researchers thought their software had suffered a catastrophic failure. They were staring at a fossil from the dawn of time that should not exist. If you love exploring real cosmic mysteries that challenge what we know about reality, take a second to hit subscribe. When you join this community, you get honest, deeply researched science stories without any hype or exaggeration. To understand why this discovery sent shockwaves through the scientific world, we have to look up into the night sky away from the bright lights of our cities. When you look at the stars, you are actually looking back in time. Light takes time to travel through the vast emptiness of space, which means we never see the universe as it is right now. We only see it as it was when that light first began its journey across the dark void. Most of the stars you can see with your naked eye are relatively close neighbors inside our own Milky Way galaxy. Some are young and hot, burning with brilliant blue flames, while others are middle-aged yellow stars just like our own sun. Our sun is about 4.6 billion years old, which feels like an eternity compared to human history. But in the grand timeline of the cosmos, our sun is practically a newborn baby. Way back in the year 1777, a French astronomer named Charles Messier was scanning the heavens with a small, primitive telescope. He was not looking for ancient relics or distant worlds. He was actually searching for comets, which were the rock stars of astronomy during the 18th century. As he mapped the sky, he kept bumping into fuzzy, glowing patches that stayed in the exact same spot night after night. To prevent other comet hunters from wasting their time on these motionless clouds, Messier created a list of objects to completely ignore. One of the objects he cataloged was given the simple label of Messier 92, or M92 for short. It looked like a tiny, blurry snowball hanging quietly in the constellation of Hercules. At the time, nobody possessed the technology to see what was actually hiding inside that faint smudge of light. It took better telescopes and decades of patient observation to realize that M92 was not a cloud of gas at all. It was a globular star cluster, which is a massive spherical swarm of hundreds of thousands of stars held together by intense gravity. Imagine taking 300,000 giant suns and crushing them into a ball of space that is only about 100 light years across. If you lived on a planet inside this cluster, your night sky would never be dark because thousands of brilliant suns would blaze overhead at all hours. Astronomers initially expected that globular clusters would simply be normal families of stars that formed together a few billion years ago. They assumed these clusters were just standard building blocks that drifted around the outer halo of the Milky Way, living and dying like any other group of stars. But when modern spectrographs analyzed the actual light coming from M92, the data revealed something that completely contradicted their expectations. Every star is like a cosmic kitchen that cooks simple elements into heavier elements through nuclear fusion. When the universe was first born during the Big Bang roughly 13.8 billion years ago, there were only two main ingredients available: hydrogen and helium. There was no iron, no carbon, no oxygen, no gold, and no silicon. All of the heavier elements that make up rocky planets, oceans, and human bodies had to be forged inside the burning cores of giant stars over billions of years. Because of this simple rule, scientists can determine the age of a star by checking how many heavy metals it contains. In astronomy, any element heavier than hydrogen and helium is called a metal. If a star is rich in metals like iron, it means it was born recently from the recycled ashes of previous stars that exploded in supernovas. But if a star has almost zero iron, it means it must have formed when the universe was brand new, before earlier generations of stars had time to pollute the cosmos with heavy dust. When researchers measured the chemistry of the stars inside M92, they found that these stars were almost completely pure hydrogen and helium. Their iron content was hundreds of times lower than the iron found in our own sun. This meant these stars were formed out of the pristine, untouched gas left behind right after the Big Bang occurred. They were not just old stars, they were ancient survivors from the very first chapters of cosmic history. To put this chemical difference into perspective, our sun has enough heavy elements to build thousands of rocky planets the size of Earth. But the stars in M92 have so few heavy elements that you could barely gather enough solid matter in an entire star system to form a single tiny asteroid. They are chemical relics of a simpler, raw era when the universe was only just beginning to produce the materials of life. Did you know that the stars in ancient clusters like this have almost no heavy metals, meaning rocky planets like Earth could never form around them? If this kind of deep cosmic history fascinates you, go ahead and drop a like on this video so more people can discover the true age of our universe. The mystery deepened when astrophysicists used advanced computer simulations to calculate the exact age of M92 based on how its stars were aging. Stars burn through their nuclear fuel at very specific rates depending on their mass. Huge, heavy stars burn their hydrogen fuel in a frantic blaze, lasting only a few tens of millions of years before blowing up in violent explosions. Smaller stars, with less mass than our Sun, burn their fuel with incredible frugality, sipping on hydrogen so slowly that they can shine for tens of billions of years. By looking at which stars in the cluster had reached the end of their lives and turned into swollen red giants, researchers could pinpoint what astronomers call the main sequence turnoff point. This turnoff point acts like an extremely accurate cosmic clock. By measuring the exact mass and temperature of the stars currently dying in the cluster, researchers could calculate precisely how long the cluster had been steadily shining. The initial mathematical models produced a number that made everyone in the room freeze. The calculations showed that M92 was over 14 billion years old. This created an immediate, terrifying paradox for modern astrophysics. The accepted age of the entire universe, confirmed by measurements of the cosmic microwave background radiation, is 13.8 billion years. A star cluster cannot possibly be older than the universe that contains it, because that would mean the stars existed before time and space themselves began. This impossible number sparked a fierce debate among astronomers across the globe. Some argued that our measurements of the universe's expansion rate, known as the Hubble constant, were completely wrong, and that the universe was actually much older than we thought. Others insisted that our understanding of stellar physics and the way stars fuse hydrogen had a massive undiscovered flaw that threw off our age calculations. Teams of researchers from top observatories reanalyzed every single data point over several decades. They checked for hidden errors in their mathematical codes and worked hard to measure the precise distance to M92 using modern space telescopes. Getting the exact distance is critical because if you think a star cluster is closer or farther than it really is, your measurement of its true brightness will be wrong, which changes your calculation of its age. After years of careful calibration and better data from instruments like the Hubble Space Telescope and the Gaia Space Observatory, astronomers refined the number to a breathtaking 13.8 billion years, with a tiny margin of error of just a few hundred million years. M92 formed right at the dawn of the cosmos, just a couple of 100 million years after the Big Bang itself. It is one of the absolute oldest intact structures known to exist anywhere in the observable universe. Think about what that number really means in everyday terms. While the Earth has existed for roughly 4.5 billion years, this cluster has been orbiting the outer edges of our galaxy for more than 3 times that entire duration. When the very first single-celled life began to wiggle in Earth's ancient oceans, M92 had already been drifting through the darkness for over 9 billion years. It watched the birth and death of countless generations of stars while remaining largely unchanged. During this immense span of time, our entire Milky Way galaxy was being assembled around these clusters. Astronomers now believe that giant globular clusters like M92 were among the very first building blocks of the galaxy. In fact, many globular clusters may actually be the dense, surviving cores of smaller dwarf galaxies that our Milky Way devoured and absorbed billions of years ago during violent cosmic mergers. Scientists originally thought that because these clusters are so unbelievably old, they would be quiet, dead cosmic graveyards where nothing new ever happens. They expected to find only dim, dying red stars slowly burning their last drops of fuel in complete silence. They pictured globular clusters as dusty museums of the early cosmos, frozen in time and slowly fading into darkness. But when our most powerful telescopes zoomed directly into the dense center of these ancient clusters, they found a chaotic world of violence and rebirth that no one anticipated. Far from being peaceful retirement homes for elderly stars, the hearts of these clusters are wild, dynamic arenas where stars are constantly interacting, colliding, and reshaping one another through sheer gravitational force. Inside the crowded heart of a globular cluster, stars are packed so closely together that they frequently interact with one another. In our part of the galaxy, the nearest star to our Sun is Proxima Centauri, which is more than 4 light-years away. That translates to about 25 trillion miles of completely empty, quiet space separating us from our closest neighbor. In our quiet cosmic suburb, stars never run into each other because space is simply too big and empty. But at the center of M92 and its sister clusters like Omega Centauri and Messier 15, the density of stars is tens of thousands of times higher than in our neighborhood. Hundreds and sometimes thousands of stars are squeezed into a single cubic light-year of space. In that extreme environment, stars do not live peaceful, isolated lives. They pass so close to each other that their immense gravitational fields pull and tear at their outer gas layers. Sometimes, 2 older stars on the brink of death collide head-on at tremendous speeds, merging together to form a brand new superheated giant star. In other cases, a dying star will use its gravity to steal hydrogen gas directly from a weaker companion, stripping its neighbor down to the bare bone. Astronomers were completely stunned when they discovered bright, hot blue stars shining right in the middle of these ancient clusters. Blue stars burn their fuel very quickly and normally die after only a few 100 million years, so finding them in a 13 billion-year-old cluster seemed completely impossible. If all the stars in the cluster formed at the same time at the beginning of the universe, every single blue star should have died out billions of years ago. Scientists nicknamed these strange objects blue stragglers because they seemed to have lagged behind in their aging process and found a way to cheat death. These blue stragglers look youthful and vibrant because they are cosmic vampires that fed on other suns. By absorbing fresh hydrogen from collisions or tidal stripping, they reset their nuclear clocks and began a brand new life cycle long after they should have gone dark. What do you think happens when two suns crash into each other in the middle of a crowded star cluster? Leave a comment below with your thoughts and make sure to subscribe so you never miss our next deep dive into space mysteries. The blue stragglers prove that even though these star clusters are older than almost anything else in existence, they are still capable of generating new phenomena through sheer gravitational power. But the surprises hiding inside these ancient swarms did not stop with vampire stars. When astronomers turned their radio telescopes toward these clusters, they detected strange, rhythmic pulses of energy flashing through the void. These signals were coming from millisecond pulsars, which are the crushed, spinning cores of massive stars that exploded billions of years ago. When a giant star runs out of fuel, its core collapses under its own gravity until all of its protons and electrons are crushed together into a city-sized sphere of pure neutrons. A single teaspoon of material from a neutron star would weigh billions of tons on Earth, having the same density as an entire mountain crushed into the size of a sugar cube. What makes the pulsars in ancient clusters so extraordinary is the unbelievable speed at which they rotate. In clusters like Messier 15, 47 Tucanae, and NGC 6397, astronomers have found neutron stars that spin on their axes hundreds of times every single second. As they spin, they sweep intense beams of radio waves and X-rays across space like giant cosmic lighthouses. Scientists originally believed that pulsars would naturally slow down and stop flashing after a few million years as they lost rotational energy to the surrounding space. Yet here were pulsars that had been active for billions of years inside ancient clusters, spinning faster than almost anything else in the cosmos. How could a dead star continue to spin hundreds of times a second after 13 billion years? The secret to their eternal motion once again came down to the crowded nature of the cluster. These dead stars were pulling gas from nearby companion stars, funneling the falling matter onto their surfaces through intense magnetic fields. As the gas spirals inward and crashes down, it acts like water hitting a water wheel, transferring rotational energy and spinning the dead star back up to dizzying speeds. These objects are known as recycled pulsars, and they are among the most precise timekeepers in the entire universe. The gravitational interactions in these clusters do not just create spinning pulsars, they also act like giant cosmic slingshots. When 3 or 4 stars pass close to each other in a tight dance, the energy of the system gets concentrated into one of the smaller objects. That smaller star, or dead stellar core, gets violently whipped out of the cluster at speeds of hundreds of miles per second, launching it into the vast, empty space between galaxies. Every time astronomers thought they had these ancient clusters figured out, a new discovery would force them to rewrite their textbooks. For a very long time, the standard scientific theory claimed that planets could not possibly exist inside ancient globular clusters. The logic seemed rock solid. Planets require heavy elements like iron, silicon, and carbon to form solid ground, and ancient clusters have almost no heavy elements at all. Astronomers assumed that the clouds of gas that created globular clusters were too chemically pure to ever condense into rocky worlds, or the massive solid cores needed to gather thick gas atmospheres. For decades, textbooks confidently stated that these ancient clusters were completely sterile regions of space, empty of any worlds, moons, or possibility of planetary systems. They were treated purely as massive stellar labs, barren of any planetary bodies. Then, in the late 1980s and early 1990s, a team of astronomers studying an ancient globular cluster called Messier 4, located about 7,000 light-years from Earth, noticed a tiny anomaly. They were observing a millisecond pulsar designated PSR B1620-26, carefully timing its radio flashes. To their confusion, the steady ticking of the pulsar was drifting slightly, speeding up and slowing down in a regular, predictable pattern. Something was pulling on that dead star with a steady, repeating gravitational tug. At first, scientists thought the pulsar was simply orbiting an ordinary companion star, which was identified as a white dwarf. But when they accounted for the pull of the white dwarf, there was still another unexplained gravitational wobble left over. There was a third object in the system, orbiting both the pulsar and the white dwarf from a greater distance. When the researchers calculated the mass and orbit of this third object, the results shocked the entire planetary science community. It was not another star, and it was not a dim brown dwarf. It was a massive gas giant planet, more than 2 times heavier than Jupiter, orbiting a bizarre pair of dead stellar corpses. This ancient world was given the official scientific name PSR B1620-26b, but the public quickly gave it a much more fitting nickname, Methuselah, after the oldest figure in ancient folklore. Careful analysis of the cluster's age revealed that this planet is approximately 12.7 billion years old. That makes it more than double the age of the Earth, and one of the oldest known planets in the entire universe. Have you ever wondered if an alien civilization could have evolved on a world that formed billions of years before our own solar system was even born? Share your theory in the comments right now, and if you're enjoying this breakdown, take a moment to subscribe and hit that notification bell. The discovery of the Methuselah planet completely demolished the old theory that planets could only form in metal-rich environments. It proved that nature found a way to build giant worlds when the universe was barely 1 billion years old. Even in an environment with almost no heavy elements, gas and dust managed to clump together fast enough to create a super Jupiter before the birth cluster ran out of raw materials. The backstory of how this ancient planet survived for over 12 billion years is one of the most dramatic survival tales in astronomy. The planet originally formed around a normal young sun-like star in the outer regions of the cluster. Over billions of years, that parent star aged, ran out of hydrogen in its core, expanded into a giant red balloon, and eventually shed its outer layers to become a dim white dwarf. The planet survived the traumatic death of its home star, remaining in orbit around the cooling white dwarf. But the story did not end there. As the pair drifted toward the crowded core of the cluster, they had a close gravitational encounter with a neutron star that already had its own companion star. In the chaotic four-body dance that followed, the immense gravity of the neutron star completely disrupted the systems. The original companion of the neutron star was violently ejected into deep space, while the neutron star captured both the white dwarf and its ancient planet into a brand new tight orbit. The planet survived 2 separate stellar deaths and a violent gravitational kidnapping, and it is still orbiting those dead cores today. It has drifted through the cosmos for nearly 13 billion years, witnessing the entire evolution of the Milky Way galaxy. Standing on a hypothetical moon orbiting this ancient giant would offer a view unlike anything in our solar system. The sky would be filled with the blinding white light of a dying white dwarf star on one side, and the rapid strobing flash of a deadly pulsar on the other. In the background, thousands of brilliant multicolored suns would illuminate the night sky with a continuous, glowing haze that never fades into true darkness. As astronomers pushed their instruments even further into the centers of these ancient clusters, they began searching for something even darker and more mysterious. For many years, scientists knew about 2 main types of black holes. Small stellar black holes formed from single exploding stars, weighing between 5 and 20 times the mass of our Sun, and supermassive black holes that weigh millions or billions of suns at the centers of giant galaxies. But they were missing the middle link in the cosmic chain. Astrophysicists predicted that intermediate mass black holes, weighing between a few hundred and a few thousand suns, should exist somewhere in the universe. The dense, gravity-choked centers of ancient globular clusters like Messier 15 and Omega Centauri seemed like the absolute perfect breeding ground for these elusive monsters. Over billions of years, the heaviest objects in a cluster naturally sink toward the center due to a process called dynamical friction, colliding and merging into an ever-growing gravitational pit. When the Hubble Space Telescope measured the speeds of stars zipping around the dead center of Messier 15, it found that the stars were moving far too fast to be held by normal gravity alone. Something invisible, compact, and tremendously heavy was anchoring the core of the cluster, whipping stars around at incredible velocities of hundreds of thousands of miles per hour. While some scientists argue that this invisible mass could be a tight swarm of hundreds of smaller neutron stars and stellar black holes, many astrophysicists believe we are looking at an intermediate mass black hole. If true, these ancient swarms hold the key to understanding how the giant supermassive black holes that rule the centers of galaxies first got their start in the early universe. They could be the missing fossils that explain how cosmic monsters grew from tiny stellar remnants into million-sun behemoths. Beyond individual black holes, astronomers have recently discovered that globular clusters are dynamic gravitational engines that produce gravitational waves. When black holes and neutron stars sink into the dense centers of these clusters, they inevitably form tight binary pairs. Over millions of years, these pairs spiral closer and closer together, eventually colliding in catastrophic mergers that send ripples across the fabric of space-time itself. Observatories like LIGO and Virgo have detected dozens of these gravitational wave events, and simulations suggest that a huge percentage of them originated inside the dense cores of ancient globular clusters. These ancient relics from the dawn of time are actively shaping the modern gravitational landscape of our universe, sending signals across billions of light years that our instruments are only now beginning to pick up. Every single discovery inside these ancient star clusters acts like a time machine that pulls back the curtain on the dawn of creation. Because these clusters are so close to us compared to distant galaxies, billions of light years away, we can study their individual stars with incredible detail. They are living laboratories where we can test the fundamental laws of physics under conditions that existed when the cosmos was young. Now, with the James Webb Space Telescope operating out in deep space, astronomers are turning their most advanced infrared cameras toward these ancient fossils once again. Webb is able to peer through the thick dust of our galaxy and resolve the faintest, coolest stars at the very bottom of the cluster's evolutionary ladder. It can see stars that were previously invisible to every telescope in human history. These ultra-dim objects are ancient white dwarfs that have been slowly cooling down for more than 12 billion years. They are like cosmic embers that have been sitting in the dark since the beginning of time. Because white dwarfs do not produce any new heat through fusion, they cool down at a mathematically predictable rate. By measuring exactly how much heat these white dwarfs have lost, scientists can calculate the age of the cluster with unprecedented precision, removing any remaining doubts about the timeline of our cosmic history. What is happening right now in modern astrophysics is a race to find the true first-generation stars, known as population 3 stars. These were the legendary massive monster stars that lit up the universe after hundreds of millions of years of total darkness following the Big Bang. They were made entirely of pure primordial hydrogen and helium without a single speck of metal, and they burned with unimaginable brightness before dying in hypernovas. While no pure population 3 star has been found alive today because their massive sizes caused them to burn out in just a few million years, ancient globular clusters like M92 and M15 are the closest living relatives to those original light sources. They were formed from the direct debris of those first stars, preserving their pristine chemistry inside their surviving low-mass members. When you look at the stars in these clusters, you are looking at the direct descendants of the first light that ever shone in the universe. The hydrogen atoms inside those stars have remained virtually unchanged since the first 3 minutes of cosmic existence. They are pure, untainted pieces of the Big Bang that you can see through an ordinary backyard telescope on a clear summer night. Another major breakthrough in recent cluster research involves what astronomers call multiple stellar populations. For over a century, scientists believed that all the stars in a globular cluster formed in a single, sudden burst of star formation. But ultra-precise chemical mapping with modern space telescopes has revealed that many globular clusters contain 2 or even 3 distinct generations of stars, separated by tens of millions of years. How a small cluster of stars managed to hold onto enough gas to ignite a second or third generation of stars remains one of the hottest mysteries in astrophysics today. Some researchers believe that the most massive stars shed huge amounts of slow-moving gas that pooled in the center of the cluster, while others suspect that the cluster plowed through massive gas clouds in the early galaxy, sweeping up fresh fuel to ignite new stars. This means that even our simplest assumptions about how stars are born are being challenged by these ancient swarms. They are not simple single-event clusters. They are complex, multi-generational communities that experience several waves of evolution before settling into the stable forms we see today. This brings us to a profound truth about our place in the cosmos. It is easy to look up at the vast emptiness of space and feel small and insignificant. We live on a tiny rock orbiting a middle-aged star in a quiet corner of a spiral galaxy, living lives that last only a few decades. But the fact that we can build machines, point them at faint smudges of light in the night sky, and decode the 13 billion-year-old story of creation is nothing short of a miracle. These ancient star clusters remind us that everything we see around us, from the iron in our blood to the silicon in our computers, is the result of a long, unbroken cosmic journey. We are made of the heavy dust that these ancient stars never had the chance to possess. We exist because generations of stars lived, synthesized elements, and exploded across billions of years of time. As we continue to explore the depths of space, these ancient swarms will continue to stand guard at the edge of our galaxy. Just as they have for nearly 14 billion years, they will outlive our sun, which will die in about 5 billion years. They will survive the eventual collision between the Milky Way and the Andromeda Galaxy, and they will keep orbiting through the dark long after our solar system has returned to dust. If you enjoyed uncovering the secrets of the oldest objects in our universe, make sure to subscribe to the channel right now and turn on all notifications so you never miss an episode. What do you think is the most surprising fact about these ancient star clusters? Drop your thoughts in the comments section below, and be sure to share this video with a friend who loves space science as much as you do. Thank you for watching, and stay curious.